Good day, students. Welcome to part 2 of the series on practicing how to differentiate using the chain rule. So you can view the first clip before this in the playlist just by clicking down here. So let's go ahead and try out a couple of examples, actually 3 examples. Let's write down instructions. Find dy dx, the derivative of the following functions. Okay? Alright, so let's go ahead and consider number 1. Let's say we have the function y equals 3 cosine sine 3x plus 1. Okay? What if we had a function like this? Now, if you notice that here we have 3 functions. The outermost one is a trig function, followed by another trig function, and then we have a polynomial function or linear function on the interior. So we're going to start from the outside, and we're going to differentiate the outermost one holding the inner 2 fixed, differentiate the second one holding the innermost fixed, and then we'll differentiate the final one on the inside, okay? So let me rewrite this by color coding it so it's obvious what I'm about to do. So we're going to have y equals, this 3 is of no consequence, so cosine, the outermost one, let's put it in black, cosine of sine is the next function in the composition, sine of, and then the innermost one, let me put it in blue, 3x plus 1. Okay? Alright, so that's the order of differentiation. Alright, now let's do it. Alright, so we're going to start with the outermost one, so I'm going to have dy dx equals 3. Now the derivative of cosine is negative sine, so I'm going to write negative sine of this entire function I have on the inside, sine of 3x plus 1. And then you notice that I didn't do anything to the inner function. I just differentiated the outermost one, okay? Times, now I'm going to now be differentiating the inner function times sine of 3x plus 1 was that prime, okay? You notice when I differentiate the outermost function, I hold the inner fixed, and then now the next step is to differentiate the next function, which is the sine. All right, so we're going to bring this down. To differentiate that, we're going to have negative 3 sine of, this one I can write it the same color since we don't need to focus any attention here anymore. 3 sine of 3x plus 1. We're done with that. Now shift our attention to this. The derivative of sine is cosine, so I'm going to change that to black. So it's going to be cosine of, now the innermost function, we'll hold that fixed, 3x plus 1, and then that times the derivative of the innermost function. The innermost function is 3x plus 1 quantity prime. Okay, so you notice the order. We did the cosine first to get sine. Now we did the innermost sine to get cosine. Now we're not going to shift our attention to the final one, which is 3x plus 1. Alright, so to finish that up, we're going to have negative 3 sine of 3x plus 1 times cosine of 3x plus 1. Now the derivative of 3x plus 1, we'll just use a power rule here. The derivative will simply be 3 plus 0, because the derivative of 1 is 0. Okay, so there you have it. Now to finish this up, I'm just going to multiply this 3 by this 3 in front. So our final answer, dy dx, is going to be negative 9 sine of the sine of 3x plus 1 times cosine of 3x plus 1. Okay, so there goes your final answer for the derivative of question number 1. Okay, all right, now let's move on to number 2. So for number 2, what if we had the function y equals the quantity 3x plus sine square x over 3 raised to the second power. Okay, what if we had this? Now within this proof, are you going to remember, we're going to be making use of an identity known as a double angle identity. So what I need you to remember is that sine 2 theta is the same thing as 2 sine theta cosine theta. Okay, so I'm going to be making use of this rule, this identity, this double angle identity later on in this differentiation process. All right. So let's go ahead and differentiate this. We're going to have dy dx is going to be the derivative of the outermost function. The outermost function is a power function, so we're going to have 2 times the inner function, let me put it in green, times 3x plus sine square x over 3. Close that. And then you subtract 1 from that, you have 1. Okay, so you don't even need to put any power after you differentiate that outermost function, because when you have the 2, the 2 comes to the front, and then you subtract 1 is just 1, so we don't even have to put anything here. So that's the differentiation of the outermost function times the derivative of the inner function, which is 3x plus sine square x plus 3. Okay. Technically, there are 3 functions here, so we're gonna be really careful with this piece right here. So let me just show that to you so it's obvious. So let me code it this way. So we're gonna have sine of the square of x plus 3, x over 3. Okay, so that whole thing we're going to be differentiating. We're going to find prime on that. All right. So before I differentiate the inner function, we're going to, let me just go over what I did here. Let's say, assuming you had u squared. Okay, if you want to differentiate u squared prime, you just use the power rule. It's 2u to the 2 minus 1, right? Which is just 2u. So that's exactly what I did here. This inner piece is like u, so just 2u. Now we're going to differentiate the inner one. All right. Okay, so let's go ahead and do that. So the y dx is going to be equal to times 3x plus sine square x over 3. I don't need to color code this anymore because the composition structure is not relevant since we're not differentiating this. This is the one that's important. So now we're going to differentiate this term by term. Notice this is a power, then a trig. There's a power of a trig function, and then inside the trig function we have this linear function right here. All right, so the derivative of 3x is just 3. And then the derivative of this power function square is going to be plus, you have to be really careful here, 2, I have to color code, 2 sine of x over, I'm color, 2 sine of x over 3. Okay, I'm color coding it so you can see the structure of the composition going on here. All right. Okay. Now what on earth just happened here? In this piece, wait a minute. If I close that, if you notice what's going on here, I differentiated this to 3. This is not a composite function, but this is a composition of 3 functions. You have the power, the trig, and then the linear. So I just did the power function. The power function is u squared. So if you differentiate u squared prime like we did up here, we just have 2u, right? So it's just going to be double of the inner function, which is sine x over 3. Okay, so this is 2 sine x over 3. Now, in this piece right here, I have to multiply by, just on the right side, the derivative of the sine of x over 3. Okay, so the part on the right is a composition of 3 functions, which makes it a little bit longer to do. So this one prime. Okay, and then we include the outermost bracket. Alright, so we're going to now focus our attention on differentiating just this inner piece, and it will be multiplied by this part right here, okay? So let's write everything down. We're going to have 2 times 3x plus sine square x over 3, close that, times 3 plus 2 sine x over 3. The derivative of sine is cosine, so it's going to be cosine x over 3. Cosine of x over 3. So in this case, it's cosine of x over 3, but x over 3 is a function on its own, so we gotta put that in red. Cosine of x over 3 times, now we're going to differentiate the innermost function, which is times x over 3 prime. Okay? Prime, and then close that. So you see right here we have two functions. We have the trig function and the linear function. I differentiated the trig because it's outer. Is that the outermost function to get cosine? Now I have to now differentiate the inner function, which is a linear function right there. Okay? Alright, so now let's go ahead and do that. So we're gonna have 2 times 3x plus sine square x over 3 times 3 plus 2 sine x over 3 cosine x over 3. Now the derivative of x over 3, you gotta be careful with that. We can write it as 1/3 x, right? X over 3 is equal to 1/3 x. If you differentiate this using the power rule, you're just gonna simply get 1/3, because this will become x to the 0 and it just goes away, so you just be left with 1/3. Alright, so it's 1/3 x to the 0, which is just 1/3. Okay, so times 1/3. Alright, you can see that everything is in black now, which means that we're done differentiating all the way into the innermost function from the outermost function. Okay, so now let's see. Now here we have sine and cosine. These are identical angles, so we have 2 sine x over 3 cosine x over 3. We can combine these two as follows. So we're going to have on the left side here, we'll have 2 times 3x plus sine square x over 3. Close that, times 3. Now remember I told you about the identity up here. Sine 2 theta is 2 sine theta cosine theta. Okay, if you have the same argument for sine and cosine, you can combine them. So this is the same thing as plus sine 2x over 3. You know, can bring this 1/3, put it in front right here, like that. And there goes your final answer. Okay, so this is dy dx. Alright, so let me go ahead and box that. Now, just to backtrack real quick. What I did over here, just in case you're lost, let me just go over that again real quick. So, I said 2 sine x over 3 cosine x over 3 equals sine 2 x over 3. Why? Because this is like 2 sine theta cosine theta, right? 2 sine theta cosine theta. So, assume this is theta, okay? So it's going to become sine 2 theta, but theta is pi x over 3, right? So that's why I have 2. It's like this is 2 times x over 3 right here. It's like 2 times x over 3, 2 times x over 3, because x over 3 is like theta. And then when you multiply it out, you just basically have sine 2x over 3. So that's why I got sine 2x over 3. It's just a combination. If you didn't combine it, your answer is perfectly fine. So that's basically how it works. Notice that this 2 goes away too. Okay, so you have that. Alright, so there goes your derivative. This is pretty interesting one to do. Now let's move on to question number 3. Question 3, what if we have the function, a position function this time, s of t equals 3 times the square root of sine 5 p squared plus t minus 1. Okay? Alright, let's go ahead and find the derivative. T is the independent variable here, so we're looking for ds dt. So it's going to be, let me rewrite this. It's going to be 3 times sine of 5t squared plus t minus 1 raised to the 1/2. Okay? This is another way of writing it, so I can use the power rule. Alright, so we're going to start from the outermost one using the differentiating this power right here. So we're going to have, it's going to become 3 times 1/2 times, now let's start color coding our functions based on nesting. From the outer one, we have a trig function here, sine of 5t squared plus t, close that, minus 1. That's, we're going to use the power rule, so we just subtract 1 from the power, right? So this is going to be negative 1/2. Now this is derivative of the outermost function, now times the derivative of the inner function. So the derivative of sine of 5t squared plus t minus 1, this whole story prime. Okay? Alright, so let's go ahead and simplify this, rewrite it in a nicer fashion, and then differentiate that. So this whole piece right here is going to become 3 divided by 3 divided by 2. Now when this negative 1/2 goes to the bottom, it's going to become positive, right? And become the square root. The square root of sine 5t squared plus t minus 1 times, now let's differentiate this. We do the outermost one, so if I differentiate sine, I get cosine. Cosine of 5t squared plus t times, you notice that we have two terms here. The first term is composite, the second is not. So when we differentiate in this first term in this inner function, we have to apply the chain rule. So that times the derivative of the inner one, 5t squared plus t prime. Okay? Prime. And now the derivative of 1, that's a constant rule, is 0, so that goes to 0, so we just forget about that. Now let's go ahead and differentiate the innermost function. So now we're going to have, write this as 3 cosine 5t squared plus t. Now let's differentiate this, term by term differentiation of this polynomial function. We're going to have 10t, applying the power rule, plus 1. Okay? And then that whole story divided by, we're going to divide that whole thing by 2 times the square root of sine 5t squared plus t minus 1. Okay? Alright, so there goes the dt, the derivative. So bottom line is you can distribute this if you want, but this is good enough. Alright? So there you have it. So thanks so much for taking the time to watch this video. Please feel free to subscribe to my channel by clicking up here. To get more videos, you can subscribe so you can get updates for cool clips such as this. You can share this contents of this video with your friends via Facebook or Twitter. More videos can be found on mathwebserve.com. Also, if you want to request free math help, you can follow me on Twitter at mathwebserve1. Thanks again and have a wonderful day.